This is video 2.1D, and we're continuing on, and we did a 30, 60, 90, and we found out that 30, 60, 90, this is 1, this is 2, this is square root of 3. What we're going to do now is look at a 45-degree angle. And one of the things we know about a 45-degree triangle is this length and this length are going to be the same. So we just have to find that one. So it's 1 squared plus 1 squared equals hypotenuse squared, or that's the c. So 1 plus 1 equals c squared, 2 equals c squared, square root of both sides. Give me a hypotenuse of the square root of 2. And that's true of any 45-degree angle. It will be in that ratio. So I do these a little bit different as far as how I name these angles, and I don't know of any book that does it this way. So you can either follow along with what I'm doing or do it the way the book does. I guess that's kind of up to you. But let's look at this. Let's look at a 60-degree angle. I'm going to call this x, this 2x, and this x square root of 3. Okay, so for instance, if this triangle were 6, then the hypotenuse would be 2x, or 2 times 6, and the side would be x, or 6, square root of 3. And I do that because then it allows you to find the measurement of any 30, 60, 90 triangle just by knowing one of the sides. Because given 1, 2, and square root of 3, it's like, well, yeah, that's true, that's the ratio. But if I call it x, 2x, and x square root of 3, if I just put an x, in everything, then if they give me any side at all in this, so let's say, for instance, if I can erase anything, probably not going to be able to do that. Let's erase everything. If they give me a 30, 60, 90, and they say this is 18, and they say find the other sides. Well, I know this one here is half of 18, because this is my x, this is my 2x, so 2 times the 9 would give me my 18. And then this one, let me get rid of these x's here now. And then the height of this would be whatever x is, 9 times the square root of 3. And I just have all 3 of my sides then. So that's why I like using those x's. The same is true with a 45-degree angle, 45, 45, 90-degree angle. This is x, and this is x square root of 2. So if I have this 45-degree triangle, and I say that this is 6, I know that this is 6, and this is 6 square root of 2. So it just makes it real quick and easy to find the lengths of the other sides. So let's look at the trig parts of these 45-degree angle triangle thingies here. Okay, so these are 45. If I want to find the sine of 45 degrees, sine of 45 degrees, this is 1, this is 1, this is square root of 2. So the sine of a 45-degree angle, sine is opposite over hypotenuse, so it would be 1 over the square root of 2. Multiply by the square root of 2 over the square root of 2, and you get square root of 2 over 2 for the sine of a 45-degree angle. Cosine of a 45-degree angle is going to be adjacent over hypotenuse, which is going to be 1 over square root of 2. So the cosine of a 45-degree angle will be, again, square root of 2 over 2. Now, cosine and sine are coterminal, or cofunctions. So look what happens. They both have the same answer, and the angles are the same. 45 plus 45 is 90. So anyway, let's go ahead and actually see what we're going to want as far as an answer goes when we start taking sines and cosines. So when you have, say, the tangent of a 30-degree angle, and I know that the tangent of a 30-degree angle, because I've been teaching this so long, is the square root of 3 over 3. if we were to take your calculator and plug that in, it's going to give you 0.577350 and it's going to go on and on. Usually what we do is stop at 4 decimal places. You don't have to go any further than that. So you might want to do 5774 and just round. So, and that's what your calculator will do. When you plug in tangent of 30, it's not going to give you the square root of 3 over 3, although that's the better answer because that's an estimate. Because look, this is just going to go on forever and ever. So this is the more accurate answer, and that's the one I like the best. But it kind of depends on what the book is asking, but I prefer leaving it in radical form. All right, so that's it for 2.1, and we'll do some problems from 2.1 problem set.